Right. Hey guys, Austin here. Wanted to show off maybe a quick way structural engineers might use Revit to automate some things in their workflow. Recently, I have been doing a lot of kind of free body diagrams, sum of forces in the X, sum of forces in the Y, sum of moments about a work point. And it's been a bit tedious, and I figure there could be a way to maybe automate this, and one of the ways you can do that is utilize Revit to kind of help out with this process. A lot of what I've been doing before was, coming in here saying I've got 500 kips or something, acting at this direction, measuring angles in Revit. I know that that's coming off at 27 degrees, doing sine and cosine, sum of moments. Um, all of it's pretty easy, but tedious, time consuming, and prone to errors. And I wanted to show a way that you could potentially use Revit to automate some of forces in the X and some of moments and Y's and all that fun stuff. Um, it's what I hope Bluebeam will eventually become, maybe a little more programmatic, maybe making a family editor type environment. But for now, if you want to learn Revit, I think the time to learn it is now, and I think it's worth the investment in yourself and maybe your firm for learning some of these automation tools. So the way you might handle this is with a something called a detail component. So if you come under the annotation tab, this is kind of where you have a lot of your kind of generic, if you want to place a wide flange family shape, something like that. But we're going to make ours a kind of a force vector type component. Um, Revit's pretty cool in that you can kind of customize this. So let's hop into how you might make something like this. We're going to need to know angles and forces and magnitudes. So keep that in the back of your mind. So the way you might do that is you come into here, new family, and then I'll pop up this screen. And then we had called that a detail component. So let's go find that. And I know I want a detail item. There's a whole bunch of other families in here, but I want detail item. When you click on that, you'll be greeted with a blank screen. Um, Let me maybe just back it up a little bit. Up at the top here, you got all your kind of standard stuff, but you'll notice that your structural tab and kind of all your 3D modeling things are gone. And you're basically just left with annotation type components. So that's what we want. We don't want this to live in 3D. Um, so let's make this family. I know I want a line and I want some form of a head. I kind of want it to be maybe 6 inches long at a minimum so I can always see it. And I like that angle. I think that angle is maybe about 30 degrees. Let's make it 30 so it looks kind of crisp. And then same thing here, I'm using, that's under, if you haven't used Revit, this angular command. And we'll click, set that to 30. And then I want to lock that so that when I drag this around, that tip and tail will kind of always stay aligned with the head there. So all that looks good. Let's give this a save just so we don't lose our work. We'll call this vector family. And okay, so I don't know if I love the black. I kind of want this to pop a little bit. Maybe it's an engineering type thing. Normally I would go under line styles to make a new line style in a project, but for some reason in the family environment, you want to be under object styles. Maybe someone that knows Revit a bit more than me will know why that is, but let's call this like vector line. Okay. I'm also kind of doing this a bit on the fly. I've certainly done a bit of homework on this, so when you get into this, it might be a little more complicated, but just know that I'm doing this a little bit on the fly. So that looks good. I gave it a little bit of a thicker line weight. Um, so um, now that we have this, let's start programming what we might need for a force determination. So one of the key things here is we're going to need to know the angle from horizontal. So let's set up a number here. We'll have to assign that to a parameter so that Revit knows where we're measuring from. And then in addition to that, once we know this angle, we can figure out sum of forces in the X and everything else. So um, let's go ahead and do that. I also kind of want to move this around. I want X and Y to be kind of positive by default. So um, let's do this, move this over to here, and then measure our angle from there. I'm trying to remember, cosine is positive here, sine is positive as well. Once you get to 90, that's, yeah, so I think that will work out well. We'll double check this once we're in the family environment. Okay, so to now kind of add the parameters to this, if you haven't done this before, you click up here, and what parameters will we need? We'll need force. Let's call this an instance parameter because it'll change on the fly. If you don't know what it means, you'll see here in a second. We're going to set this to a number, and we'll come back to the shared parameters. That'll be something for tags, but if you want to kind of give a description to this, let's say full force or something like that. This helps for people that maybe don't know the family fully, but they are using it. If they hover over this, you can give some guidance on what this might mean. So that's good. We need force X, and that will also be a number. And let's say force times cosine. And then similarly, I'm going to skip all the formalities here. Force Y, you can do all this stuff. Number, that looks good. And then I know, let's set a default value here to like 100. I know I want force X to always be force. And then this is kind of, I don't know, call it the poor man's programming. Force times angle. I don't have angle yet. Let me define angle here. And then poor man's programming, you can see they've got all these kind of data types here. This is kind of forcing types on you. So when you come in here, make sure you pick the right type of data that's going to be stored. That looks good. And then now these formulas should work. So force times cosine of angle. And then you'll notice this goes from kind of a blank, you can fill in the blank here, to grayed out. And it helps if you can spell. And that's good. And then set that to sine. In here, you don't have a ton of access to differing functions, but by default, Revit comes with cosine, trig functions, arctangent functions, and stuff like that. So it works well. So now if I change this to be 200 and hit apply, at an angle of 0, it's doing its thing. And at an angle, I hit OK, at an angle of 45, you can see it's doing its thing. But what you will notice is I want this to be kind of tied to the angle. I want the vector itself to kind of rotate. So the way you do that is you come into here and you click on the dimension, and then you assign the value to that. So you can see that's now kind of snapping. This will make more sense once you load it into your project. But you can see it kind of nicely dynamically updates. Let's set this to 90. It's acting vertically, that looks good. And key thing with making families is kind of throwing everything you might expect. Let's throw 360 at it. That makes sense. It's not breaking. Let's set 225. Oh, that doesn't look good. You can see the head has kind of moved down. Let's see if we can't fix that. How would I do that? That might be backing up a bit. Let's go back. I think I might need to lock the head to there. That might work well. So what I just did there was I basically said that the head of this element has to stay attached to the insertion point. Let's see if that works. And then we'll basically rebuild this. That shows some of the panes. It's pretty easy to over constrain your Revit family. So let's see if this works or not. Again, just adding these angular dimensions back in. Keep hitting F1. Got a new keyboard. I like it, but it's a little bit finicky. And then let's set these back to the red lines. That looks good. And then set my angle after I go back to where I like it from. I want it to be positive. Angular. Okay, let's play with it again. 45. That looks good. 225. That looks good. 360. It's looking good. 0. That's good. 180. It's flipping around. Okay, seems like it's working well. So that was a good example. I hadn't tested that out yet, but again, what we did there was we locked the end of the line to this insertion point. So that works well. And then just cleaning this up. Okay, what else do we need? It should be calculating all these values correctly. That looks good. One thing that I'm a little worried about is maybe, or maybe not worried about, but what I want to happen is have this length kind of scale with the value of the axial force. So how would we go about doing that? I think one thing that we could do is maybe draw in a reference line here. And let's do the similar thing here of locking this point. What did I do before? I can't remember. Line that to there, and then that. Oh, that's over constrained. Let's see, how can I get that locked onto there? Maybe that'll work. Let's try it. I doubt that'll work. If I set that locking, this would over constrain this sketch. Okay, that was my fear. Let's hit delete on that. Maybe what we can do is pull this value out. Hopefully that stays. I think it does. So let's set that to a reporting value. So reporting just means it is what it is. And let's do, that would be a length. Standard length, I guess. And then I want maybe 50 kips to be 6 inches. So we can play with this. So let's call a scale factor. Let's just make this a type parameter. I want all of my values to be this. So let's give this a number. Type an instance. Like I said, you'll if you don't know what it is, it's not that important. But instance means you can kind of change it quickly. Type is, or type means instance change quickly. Type, you got to be a little more exact with changing it. It's a little less prone to user error. It'll make sense in a bit if you haven't seen it before. So let's set this to 1, and then length calculated. We'll set this to an instance. and we'll say this will be force, and I said I wanted it to be 50 is 1 foot, so force times 50 times scale factor times length. And I don't have length. Let's just control that. Oh, standard length. That's what I called it. Okay, that looks good. Why is it giving me 0? Force divided by 50 times scale factor. Oh, I haven't assigned that variable yet. I see. And maybe I don't call it a reporting variable. Let's set U just to an instance. Okay. That looks good. Then I'm not quite sure why it's this saying 0. Scale. That's good. Times 50, or right. So if I set this, oh, 1 foot times 12, that should be good. So I set this 50. Oh, that's why. That's why. Oh, I see. I see. I need standard length. Well, length count. I should have done that, but I see now. Force times scale factor divided by 50. So that's up. Okay. I need force times standard length. That's gonna be a big number. Yep. Divided by 50. That's good. Okay. And then let's set this to 1 foot. Okay. This is working well. Okay. And then length final is going to be equal to if so I'm trying to enforce a minimum now, minimum length on this, so that it doesn't kind of disappear. If length calculated is less than, let's say, 6 inches, and again, this is kind of that rough formula that Revit comes with by default. So if length is less than 6 inches, give it 6 inches. Otherwise, length calculated. Okay, that looks good. And then think I want to set this to a type parameter. And I want to set you to length calculate. Okay. So let's hit save on this and see if this works. So if I change this to be 100 feet, the final length should probably be 2 feet, which you can see it grew. And then if I set it to 25 feet, it should be 6 inches or 25 kips. And it is. So that's working well. Let's load this into our project environment. And now you can start to play with it. Let's come back over to here. So set this to 0. You can see it's getting that correct. What I'm not seeing though, oh wait, no, there it is. So that's looking good. I don't love how long that is. If you're dealing with smaller values, you can change the scale factor. I was hoping that would change the length of it. Why is it not changing it? So let's set this to 400. So it should be, oh, I guess it was. Okay, so that's good. By default, it's 4 feet or 8 feet. Let's come back over to here. So if I change the scale factor to, let's say, 0.25, it should be 2 feet now, which it is not. Let's see why that is not working. Oh, that's why. I don't have it in my formula. Save, and then load into the project. Overwrite. Okay. So I got 200 kips. If I bring this down to 1 foot, that is 8 feet long. Yeah, okay, that's good. And then if you start playing with this, let's bring this down to 25. It should be 6 inches. Yeah, that's great. Okay. Let's bring this back up to 100 and set this to 90. That's good. Vertical 135. That's a positive y, negative x. Okay, I'm liking this. Great. To get this aligned, it's 27 degrees. And then you can use the move command to get it. One thing that I would like to do, let's say I set this back to 0, and maybe some Revit gurus can figure this out for me, but one thing, if I wanted to, I would love for this family to be able to know that this was rotated. You can see it still thinks it's horizontal. So it's kind of got its own, maybe call it local coordinate axis, which is a little unfortunate. But it would be nice to get that to dynamically update. Maybe some Revit pros might know how to make that happen. But for now, if you want to change this and get your forces updated, be sure to use this parameter up here. Okay, so that all looks good. The next thing that might be helpful is I want to tag and see these values without having to click on them. So the way you might do that is something called shared parameters. Shared parameters are a little bit deep into Revit and you don't really need to know how to use them. I don't exactly know how to use them either, but let's start into this. If you come back under here, shared parameters, again, don't really know how they work, but let's click on this. I want to show force X, force Y, maybe. So let's do edit parameter and shared parameter select. I've got a kind of blank group here. If you didn't see that, you can say create a group. But for now, I'm going to say create a new parameter. Call this force. And that's a number that we know. Full force, I guess. X. Well, good. And blah, 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 blah. Let's just do force Y. Okay, that's all good. And instance, that's all good. So I've changed that to a shared parameter, I believe, and I'm flying by the seat of my pants here. I haven't done this yet myself, but done it a couple of times. And let's make you force Y or force X. And let's make you force Y. These processes are a little annoying, but so hit save on that. So right now we haven't really done anything, but eventually I want to be able to display these values. And what we need to do now is do a new family. And I think it's called like annotation. Yeah, annotation detail tag. I don't see detail. Maybe it's generic tag. I think that's probably it. Okay. And then what you want here from memory is a label. And I need to bring in a new parameter. Parameter services. I don't think this is where I'm supposed to be. I think it's a new parameter. Select. Yeah, here we go. And I want force. Let's get it. Select force X. That's good. And we'll add U. Force Y. And let's add U. I don't know, you can change this, but it's going to be a prefix, and then let's do a break, and then fx, and then fy, and then you'll kind of get a preview of what this looks like. And I don't love that, so let's edit this. And if I do a break, yeah, that looks better. And I kind of want it maybe in the lower right element. And we'll call this force vector. I'll be sure to post these somewhere if this works. Probably up to my GitHub. I'll put a link in the description. So force vector. That looks good. Save. And then I think if we just, I think I need to delete this because it says delete. And let's load that into there. And then over to my free body diagrams. And what do I call that? Oh, I think that's my problem. This is definitely not a generic model. So we're going to recreate what we just made. This is definitely a detail component, detail item tag. So that's what I need. Sorry about that. New family. I think it's under annotation still. Where is the detail item? What we're gonna do is just edit edit this family. Sometimes you can do this and kind of back into it. I have no idea why I can't find this family. Detail item tag. All right, anyways, do file, save as. First, detail item tag. Okay, that's fine. Delete, delete, edit label. Can't select many of these, but let's do you. Okay. Break, break. That looks good. And then this one has some detail lines. So I guess I really don't like the detail lines, but I'm gonna get rid of this. Save, load into project. And let's hope that this works. Come over to here. And it's not working. Why is it not reading it? All right, when in doubt, chat GPT. Let's see. Something easy that I'm missing here. Force, force, force. Family. Ken kind of doing this on the fly, but you're figuring it out with me. So let's come over to here. Force. That was incorrect. Maybe that's why. Oh, that's why. Force. Take tag. Oh, nice. Looks like it's working. Okay, I don't know what I just changed, but that's the beauty of tags. And I don't really like the leader. And what else do I want? I want this to look better. So let's edit this. I want some prefixes, so I'm gonna say PU, FX, FY. Okay, and maybe I want a dash, dash, and dash. And I only want to show maybe 1 decimal. I think there's a way to do that. Maybe not. Save. And I kind of want a prefix too. I want to say my units, so let's do save, load into project. Need to make it bigger. You really want to close it, but it should work. Yeah, it's looking good. So now this tag is super helpful. Let's zoom out here. I guess I really don't like how long that vector is. I want this to be shorter. Let's do the 0.5. And let's make you 0. So yeah, this is working well. Let's also, make this maybe 100 kips. Yeah, so that's super cool. And then maybe when we come back, or when I get back to it in a week, let's bring this up and around. And let's say this is 2 hundo, and the tails are adding up nicely, and it's kind of to scale, and it's looking good. I'm liking what I'm seeing. Oh yeah, that was at 27. And then let's tag you. Let's say maybe this is, another 200 kips. Annotate tag by category. And then again, I don't like the leaders. You can also get this like rotated model. Oh, I thought that might change, but maybe not. But we can start to add some of forces in the X and some of forces in the Y, and moments about a point with a little more logic. Might show off some dynamo or some C sharp, maybe both, because dynamo and C sharp are great ways to kind of start to programmatically do some of this stuff. If you have any questions about family creation, I've got another kind of more complicated one coming up on, I made a kind of a fun CLT detail component, and we can go into that too. This one was way more complicated. But that's how structural engineers might use Revit to automate some of their tasks in their day-to-day design life.